Hello dear friends, welcome back to MACSGATE. We are learning probability. Probability is a common subject for all the branches and especially for data science and artificial intelligence branch, we have more concepts. So we divided probability into three topics: probability and statistics part 1, which is common for all branches. We already completed two parts. In the first part, we discussed the introduction to probability, and in the last session, we started with the combinatorial probability. Don't worry about the name, what it tells: probability using counting techniques. That is, finding probability of events using counting techniques. Okay, so we already started, so let us continue with the problems, my dear friends. Okay. So yesterday we done this problem. So let us quickly recap and continue with the more problems, and we move on to permutations and combinations with repetitions and permutations with constrained repetitions also. Right? Suppose a committee of 5 is formed from 6 boys and 7 girls. What is the probability that the committee has at least 2 girls? So when you are selecting 5 committee members from 6 boys and 7 girls, these are the possibilities, my dear friends. You may select 5 boys and 0 girls, 4 boys and 1 girl, 3, 2, 2, 3, 1, 4, 0 boys and 5 girls. Okay. Now out of this, which of the cases are favorable for your problem? We want at least 2 girls. At least 2 girls means here you see number of girls. Here we are having total 7, and out of that you are selecting at least 2. At least 2 means 2 or more. So you want these 4 cases. Okay. So what is the probability that the committee is having at least 2 girls? And we already know that total is 13C5. So the numerator, when you use the direct method, the numerator would be these 4 cases. We need to find the how many possibilities are there, and if you add up, you are going to get committee has at least 2 girls. Okay, that is number of cases favorable for committee is having at least 2 girls. So what is this equivalent to? It is equivalent to 6C3 into 7C2, and this, that is number of ways of selecting 2 boys and 3 girls, is equal to 6C2 into 7C3, and this particular case gives you how many possibilities? 6C1 into 7C4 possibilities, and this particular case provides how many possibilities? 6C0 into 7C5. Is that clear? So what is the probability that the committee is having at least 2 girls? That is 6C3 into 7C2 plus 6C2 into 7C3 plus 6C1 into 7C4 plus 6C0 into 7C5. So that is the direct method. You can also try this problem indirectly. So how to solve this problem indirectly, sir? See, whenever the question is probability of at least k, we can always solve it indirectly like this: 1 minus probability of at most. If it is at least k, then it is at most k minus 1. So what is the probability that the committee is having at least 2 girls? That is nothing but 1 minus probability that the committee has at most 2 minus 1, that is 1 girl. So at most 1 girl means these 2 cases. So what is the answer for this, my dear friends? So the answer is 1 minus. So denominator is anyhow 13C5. So how many cases are for this particular case, how many favorable values are there? 6C5 into 7C0, and for this case there are 6C4 into 7C1 possibilities. Okay, so what is the answer for this? 6C5 into 7C0 plus 6C4 into 7C1 possibilities. Is the idea clear? Right? So that is the answer, my dear friends. So please note this. You can remember this as a formula also. whenever you want in any problem probability of at least k, that is equal to 1 minus probability of at most k minus 1. And some people also have this particular problem. See my dear friends, when you say at least k, the meaning is greater than or equal to k. And when you say at most k, the meaning is less than or equal to k. Please note this point, my dear friends. Clear? The next question. Suppose the committee of 5 is formed from same question. What is the probability that the committee has at least 2 girls and at least 2 boys? Of course, we know the possibilities. That is, a committee of 5 can be selected from following 6 disjoint possibility only. There is no other way we can select, 5 members from 6 boys and 7 girls. Here total 6 boys are there and 7 girls are there. Now you want at least 2 girls. At least 2 girls means what, sir? 2 or more. So these 4 cases. And what do you mean by at least 2 boys? What do you mean by that? 2 or more boys. But you want both the conditions to be satisfied. How many cases favorable for both the conditions? These 2 cases are favorable for both the conditions. So what is the probability that the committee is having at least 2 girls and at least 2 boys, my dear friends? These 2 cases. So for this case, how many possibilities are there? You need to select 3 boys from 6, that can be done in 6C3 ways. You need to select 2 girls from 7 girls, that can be done in 7C2 ways. So for each of the 6C3, we can do selection of 2 girls in 7C2 ways. Then how many ways this is possible, my dear friends? 6C2 into 7C3. So what is the probability that the committee has at least 2 girls and at least 2 boys, my dear friends? Denominator is 13C5 and the numerator is 6C3 into 7C2 plus 6C2 into 7C3. Is the idea clear? So any such combinational question can be asked, my dear friends. Any such combinational question can be asked. You just need to understand the situation and solve the problem. Suppose I can ask you the question, something like, what is the probability that the committee has at least, say, 2 girls and at most 3 boys? See, sometimes such a situation may not be possible. We just need to verify that. See, we always know this situation, my dear friends. If you want to select, committee of 5 members from 6 boys and 7 girls, the possibilities are this: 5 0, 4 1, 3 2, 2 3, 1 4 and 0 5. And when you want at least 2 girls means 2 or more girls, these 4 cases. At most 3 boys means 3 or less boys. 3 or less boys means what, sir? These cases. So they are actually same. They are actually mentioning the same thing. At most 3 means 3 or less boys. So these 4 cases. Suppose if I say instead of at most 3 boys, if I say at most 2 boys, then instead of this, we are having 2 or less boys. That is, at most 2 means maximum 2, less than or equal to 2. So what is common for this? These 3 cases. So you just need to understand what is this, or how many cases favorable for this and how many cases favorable for this. The common cases will be your answer. You just need to understand that, my dear friends. Okay. So depending on the given question, try to see from this table, identify how many cases are favorable for that particular situation and solve the problem. Am I clear? Sometimes we can do directly, sometimes you may do it indirectly, my dear friends, depending on the problem. Am I clear? The next one, what is the probability that the committee has at most 1 boy? See, at most 1 boy means what, sir? These are the situation, 1 or less boys. So this is boys, we are having 6 boys, 7 girls. At most 1 means these 2 situations. Actually here, the direct method is much better. Direct method is much better. Don't go for indirect, because indirect is costly. 1 minus all these 4 cases you have to do it. Here direct method is simple. So denominator is 13C5 and numerator is at most 1 boy means these 2 cases. That is the first case. For the first case, how many possibilities are there? 6C1 into 7C4 possibilities. For the second case, how many possibilities are there? 6C0 into 7C5 possibilities. Hope you understand. Is the idea clear? Now this is one question. A company is hiring to fill 4 managerial vacancies. The candidates are 5 men and 3 women. So we are having 5 men and 3 women. So this is the situation, sir. We are having 5 men and 3 women and we are selecting 4 members. See here, if you observe, maximum women here are 3. So there is never we get the possibility of selecting 4 women because we are having only 3 members, 3 women members available. So the 4 selection can have maximum 3 women in this. Please note that point. Okay. So here we are making a selection like, we are having men and women. And you want to make a selection of 4 members. Here 5 men and 3 women. How can you make a 4 member selection? Okay, the 4 members are for managerial or whatever post, my dear friends. How can you make a 4 selection? You can have 4 men and 0 women, that is possible. 3 men and 1 woman is possible. 2 men and 2 women also possible. 1 man and 3 women also possible. But 0 men and 4 women is not possible. Okay, so actually you can do this total selection. That is, you want to select 4 members from 5 men and 3 women in how many ways? That is, selecting 4 managers total from 5 men and 3 women can be done in how many ways? We just need to select 4 out of 8 members. That is 8C4. That is total. Am I clear? Now here in this question, what is he asking? If every candidate is equally likely to be chosen, then what is the probability that at least 1 woman is selected? At least 1 woman is selected means what, sir? 1 or more women selected. So these 3 cases are favorable. So if you want to do directly, what is the probability that at least 1 woman selected? So what is the answer, my dear friends? Denominator is 8C4 and the numerator these 3 cases. So how many possibilities for this case? 5C4 into 3C1. How many possibilities for this case? 5C2 into 3C2. How many possibilities for this case? 5C1 into 3C3. But this is a longer approach because here indirect approach is much better. So what is the probability of getting or selecting at least 1 woman is same as 1 minus probability of selecting at most 1 minus 1, 0 women. That is not selecting any woman. You can say 1 minus probability of no woman selected. So what is it? Denominator is 8C4, numerator is this case. So how many possibilities for this case, my dear friends? That is 5C4 into 3C0. Of course, if you know 3C0 is 1, you can ignore that. But logical answer I am writing. See, I am not writing the final answer because it is, gate question. You can simplify this to get the required answer. Maybe up to 2 decimals, you can write down your answer, my dear friends. Am I clear? So that is the answer for this problem. So just read the question carefully. You can easily answer such questions. See, generally some people say they are all not useful. The counting method, the combinatorial probability, it is never mentioned in syllabus of mechanical, my dear friends. But you can see this question, okay, in gate paper. Okay, it is been happening many times, my dear friends. I'll show you some important questions. That type of question is asked in gate almost, if you see all the branches. Okay, you can see the similar type of question in gate almost 15 plus times. Okay, so I'll show you that particular variant, which is very, very important. Today I'm going to discuss that particular variant. Right? Okay. This is not the variant. This is also one of the gate question only, but it is for gate mathematics branch. It was asked. Okay. From 6 positive and 8 negative integers, we are having, see, it's like, 2 categories. Earlier problem we are having men and women. You may have boys and girls. Okay, you may have cats and dogs. You may have monkeys and donkeys. It does not matter. I just see it like two categories. We are having category 1 and category 2. See, always see this like this. Then the same problem if they ask in a different way, you can easily answer. But here, because they are numbers, they can ask you something related to numbers in the question. Am I clear? The question may be asked in such a way that the numbers can be added, subtracted. You may find the product of numbers. Such question can be formed. If they are members, see, for human being, you cannot multiply them, right? So in such cases, the questions related to them, at least selecting at least 2, at least 3, this kind of questions will be asked. So here that at least 2 or at least 3, that kind of situations happens indirectly in these cases. That is the idea. From 6 positive and 8 negative integers, 4 integers are chosen at random and those numbers are multiplied. What is the probability that the product of selected integers is positive? So first of all, without any restriction, what is the total probability? That is, we want to select number of ways of selecting 4 numbers or 4 integers from 6 positive and 8 negative integers. How many ways you can select 4 integers from 6 positive and 8 negative integers? It is without any condition. So what is the answer? It does not matter whether they are positive or negative, sir. Total 12 numbers are there. From that you are selecting 4 numbers, or total 12 integers are there. From that you are selecting 4 integers. So what is the answer? Total, sorry, not 12, 6 plus 8 is 14. Be careful. Total 14 integers are there. From that you are selecting 4 integers. So 14 you are selecting 4, my dear friend. This is without any restriction. But in the problem there was a question. Okay, there is a condition or a constraint applied. What is the constraint applied? What is the probability that the product of selected integers is positive? So first let us see the possibilities here. So we are having positive numbers and negative numbers. We are having 6 positive and 8 negative numbers, and we are selecting 4 numbers. How many ways you can select 4 numbers, sir? You may select like 4 positive and 0 negative, or you may select 3 positive and 1 negative. These are the possibilities. I am writing all the possibilities. 2 positive and 2 negative, 1 positive, 3 negative, and 0 positive and 4 negative. These are the possibilities, my dear friends. Out of these possibilities, how many are favorable for this situation? That is, product of the numbers should be positive. See, obviously, if you are having even number of negative numbers, like 2 negative numbers, if you multiply, obviously it becomes positive. If you are having 4 negative numbers, if you multiply, you get positive. But whenever you are having odd number of negative numbers, if you multiply, you get negative sign. Positive numbers always give you positive answer only, but negative numbers will decide here. So how many negative numbers we should have? Even number of negative numbers. So what are the positive or favorable cases for this product to be positive, my dear friend? Product of integers to be positive? The favorable cases are the cases where number of negative numbers are even. That is, if you are having 0 negative numbers, no problem, product will be positive. If you are having 2 negative numbers, product is positive. If you are having 4 negative numbers, product is positive. So these are the 3 cases which are favorable. Means which give you the product of 4 integers positive. So what is the probability that the product is positive? Of course, denominator always the total possibilities, that is 14C4, and the numerator, how many are favorable for these 3 cases? How many are favorable for the first case? 4 from 6, that can be done in 6C4 ways. For each of the 6C4 ways, how can you select 0 negative numbers from 8 negative numbers? That can be done in 8C0 ways, followed by this one. For this case, how many favorable or how many possibilities are there? 6C2 into 8C2. And for this case, how many possibilities are there? 6C0 into 8C4. So that is the situation, my dear friends. So from this, you are going to get the required answer. Hope you understand. Clear? That's it. Simplified to get the required answer. I think 0.504 something you should get as the answer. Please verify, sir. See, the answers generally I don't remember. Sometimes I may remember, but don't believe my answers. Simplify to get the required answer. Is that clear? Next one. And this is the most important problem. Make a note of it. Here I am going to tell you one very, very important concept using this particular example. If you understand, as I mentioned, there are many questions, even very recent past, you can find the questions based on the similar concept. Am I clear? You can easily answer them, my dear friends. Just understand the idea behind this particular concept. Clear? Look at this. A box contains 4 red balls and 6 black balls. So in the box we are having 4 red balls and 6 black balls. Very good. 3 balls are selected randomly from the box, one after another. So we selected 3 balls from this box, one after the other, without replacement. That is, you selected one ball, you not replaced, you thrown it somewhere. Again you selected the second ball. Again you selected the third ball. This is what happened. You selected balls one after the other without replacing the balls. Hope you understand the situation. Now the question is, the probability that the selected set contain 1 red and 2 black balls is what? What is the probability that the selected set contain 1 red and 2 black balls is what? This is the question. Okay. So we selected 3 balls one after the other without replacement. The question is, what is the probability that the selected set contain 1 red and 2 black balls? See, here I'll ask you one question. In the question he asked, we selected 3 balls one after the other without replacement. What is the probability of selecting 1 red and 2 black balls? This is the favorable situation, or this is the situation we are looking for. Okay, or this is the case we are looking for, where we need to select 1 red and 2 black balls. Now my question is, the selected balls, that is 1 red ball and 2 black balls, what you selected, is it in the same order? Is it in the same order? That is, first you selected red, then you selected 2 black balls. My question is the order mentioned or not? Order is mentioned or not? Just try to understand, this is a very important concept. See, the probability of the selected set which you are looking for, that particular selected set, whatever set you are talking about, is it an ordered selection or order is not mentioned? That you try to understand. If anyone watching live, you can reply, my dear friends. Is the order mentioned or not? That is very important point to be noted. He just mentioned 1 red and 2 black balls to be selected, but he never mentioned that first red is selected, then 2 black balls selected. Nothing is mentioned like that. So here order is not mentioned. The order is not mentioned. Whenever the order is not mentioned, this problem can be solved in 2 ways. We can solve this in 2 ways. Okay, the same problem can be interpreted like this. The same problem can be interpreted like this. 3 balls are selected. Actually, what happened? The 3 balls are selected one after the other without replacement. But you can just say that 3 balls are selected, and you can just find probability of selecting 1 red and 2 black balls. You can just find probability of selecting 1 red and 2 black balls. See, here we are having 4 black balls and 4 red balls and 6 black balls. What is the probability of selecting 1 red and 2 black balls? See, here 3 balls are selected. So what is total here? What is total here? Total means there are total 10 balls. From that you are selecting 3 balls. That is 10C3. And what is the favorable situation? You need to select. What is the favorable situation? We need to select 1 red and 2 black balls. How can you select 1 red and 2 black balls from 4 red and 6 black balls? So this can be done in 4C1 into 6C2 ways. So for this particular event, these are the favorable cases and these are the total cases. So what is the probability of this particular event, Babu? Denominator is total possibilities, that is number of ways of selecting 3 balls from 10 balls. In 10 balls we are having 4 red and 6 black balls. And how many are favorable? This many are favorable, that is 4C1 into 6C2. 4C1 into 6C2. Hope you understand. So let me simplify this, sir. 4C1 is 4 only. 6C2 into, so it is like 6 into 5. 4 factorial cancel and by 2. And 10C3 is nothing but 10 into 9 into 8 upon 3 into 2 into 1. Okay. So you can simplify this. 4 into 3 into 5. So what is the answer for this, sir? 5 2s. And it is 4 2s, 3 3s. Again, this 3 cancels with this 2 cancels with this. Ultimately, you get 1 by 2, which is 0.5 is the answer. 1 by 2 is the answer. So what is probability for this event? 1 by 2. But actually, I not solve the given problem. If you observe, I not solve the given problem. What is the given problem? We selected the 3 balls one after the other without replacement. But what I done? I solved a problem where I selected 3 balls from the box. What is the probability that 1 red and 2 black balls are selected? But I am claiming that this answer is exactly same as the answer for this one. What is the answer for the original problem, sir? What is actually original situation? 3 balls are selected one after the other without replacement. What is the probability that 1 red and 2 black balls are selected? So now you need to understand the favorable situation, my dear friends. What is the favorable situation? We need to select 1 red and 2 black balls. But here order is not mentioned. Order is not mentioned. So because order is not mentioned, 1 red and 2 black balls can be selected like this. First red ball is selected, then black is selected, then again black is selected. Or first black is selected, then red selected, then black is selected. Or first black selected, again black selected, then red selected. These are the 3 cases, sir. So 1 red and 2 black balls can be selected in these 3 ways, my dear friends. Okay. Now let us see this. So I am going to handle the 3 situations because we selected the 3 balls one after the other without replacement. So 1 red and 2 black balls can be selected either this way or this way or this way. So I need to handle these 3 situations, my dear friends, one after the other. First, let us handle the first situation. So we are having 4 red and 6 black balls. First, we selected red ball from this. How many ways we can select red ball from this, my dear friends? Because here we are having 4 red and 6 black. How many ways you can select red ball from this? Red ball can be selected, that is 4 favorable out of 10. So red is removed. Now we are having 3 red balls. Next, I want to select black ball. How can you select black ball, my dear friends? 6. Now how many are available now? 9. So 1 black ball is gone. Now 5 black balls available. Now you want to select black ball. How can you select black ball now? 5 favorable out of 8. So first red and next 2 black balls are selected in this many ways. Now first black, then red, then black ball can be selected in how many ways, sir? Let us see that situation also. 4 red are there and 6 black balls are there. First black ball can be selected in how many ways, sir? 6 by 10 ways, because 6 are there out of 10. So 1 black ball is gone. Now 5 black balls are present. Next you want to select red ball. How can you select a red ball now? The red ball can be selected in 4 out of 9 ways, because 4 favorable out of 9. So red ball is gone. Now 3 red balls are there. Now you want to select black ball. How many ways you can select a black ball now? 5 favorable out of 8. Now the third situation. So now we are having 4 red and 6 black balls. So now tell me how many ways you can select black ball, my dear friends. 6 out of 10. So 5 remaining. Now again black, 5 out of 9. 4 remaining. Now red, 4 out of 8. So if you simplify, you can check your answer, my dear friend. It is 1 by 2 exact. It is because denominator is anyhow 10 into 9 into 8. The numerator part. So it is 4 into 6, 4 into 6, 4 into 6 is common. You can take 4 into 6 common. Remaining is 5 plus 5. And all are same or what? Okay, 5 only. Okay, I think 3 times. It is like, 3 times 4 into 6 into 5. 3 times 4 into 6 into 5. So I can simplify this, sir. Okay, 5 twos. Then 3 threes. This is 6 gone, 4 twos, which is 1 by 2. And this answer is exactly same as this answer. My dear friends, whenever the order is not mentioned, selecting 1 red and 2 black balls is exactly same as, that is, whenever the order is not mentioned, whether you select 3 balls one after the other without replacement or selecting 3 balls at a time, it is one and the same when the order is not mentioned. This is a very important point to be noted. If you understand this type of problems, they ask very regularly in your examination, you can easily answer. Okay, you don't have to worry about it, because this method will get the answer faster, because this and this are one and the same. When the order is not mentioned, whether 3 balls are selected at a time or 3 balls are selected one after the other, are one and the same. Okay, please note this point. This is the most important point to be noted. Okay, see, counting wise, the answers are different, but the probabilities will be same. Okay, whenever the order is not given. Please note that point. Of course, we already solved it. Now look at this problem, sir. Okay, it looks similar to the previous problem, but there is a small change in the situation or the question. A box contains 4 red and 6 black balls. Wonderful. 3 balls are selected randomly from the box, one after the other without replacement. Now see the question. What is the probability that first red ball and next 2 black balls are selected? See here, order is mentioned. So whenever order is mentioned, you have to follow the order. Okay, you have to follow the order. So what is the favorable situation, Babu? First red and next 2 black balls are selected. First red and next 2 black balls are selected. So we are having 4 red balls and 6 black balls. First red is selected. How many ways you can select red balls, sir? 4 out of 10 ways. 1 red is gone. Next black is selected. 6 out of 9. 1 black is gone now. Next black is selected, that is 5 out of 8. Simplify to get the required answer. So what is it? 4 twos, 5 twos. Then what happens to this? 2 threes and 3 threes. So what is the answer? 1 by 6. Here you cannot take it like, all the 3 balls are selected at a time. Here we need to consider the same order, because whenever the order is mentioned, you have to follow the favorable situation and accordingly. That is, first ball selected in how many ways, second ball selected in how many ways, third ball selected. The same order we need to follow, because here order is mentioned. Hope you understand. Please note this point. It is one of the important problem which is asked very regularly in your GATE examination. Both variants are asked in your examination, my dear friends. So please check whether order is mentioned or not. If order is not mentioned, selecting 3 balls one after the other without replacement or selecting 3 balls at a time is one and the same. Please note this. Now look at this. This is also GATE question. A box contains 15 blue balls and 45 black balls. It's a GATE question, 2021 GATE question. Not far away, sir. It is a very recent GATE question. Okay, 15 blue balls and 45 black balls. If 2 balls are selected randomly without replacement, so you selected 2 balls without replacement, then the probability of an outcome in which first selected ball is blue and the second selected ball is black. So please tell me whether order is mentioned or not. Order is given or not. Order is given or not. If order is given, you have to go with the favorable situation. What is a favorable situation? First ball is blue ball and second ball is black ball. So here what we are having, sir? We are having 15 blue and 45 black. So first blue ball can be selected in how many ways, sir? 15 out of 60. One blue is gone. Am I clear? Because it is without replacement. Then what happens? Next, black ball can be selected in how many ways? 45 by 59 ways. So it is 15 fours and 45 by, so if you see 45 is there only in the one numerator, so 45 by 236 should be the answer. A is the answer for this. Is the idea clear? Because the order is mentioned. Clear to you all? So that is about combinations without repetitions. So we already completed permutations without repetitions and combinations without repetitions. So whenever it is permutations without repetitions, what is the formula? R permutation of n objects is given by NPR. And what is the formula for that? N factorial by n minus R factorial. And what about combinations without repetitions? Combinations without repetitions, it is NCR. What is it? N factorial by R factorial into n minus R factorial. So that is the answer. Is the idea clear, sir? Clear to you all? Wonderful. Now let us move on to the permutations with repetitions. Permutations with repetitions. So here we are looking for R permutation of n objects with repetition. So it is not like, selecting 4 people out of 10 people. It's not like that. Because 4 out of 10 people, the 10 people cannot be with repetition. Okay, you may be selecting 4 fruits from 10 varieties of fruits where each fruit may be having any number. Like, you are selecting 4 fruits from mangoes, oranges, grapes or something else. Okay, maybe 10 types of fruits where each type of fruit is having unlimited supply. Am I clear? So here objects with a repetition. So you are making a R selection. You are making a R selection of n objects. Here these objects are like, n types where each type is having unlimited supply. Where each type is having unlimited supply. So how many ways you can select the first one? That is, we need to make a R selection or R arrangement. Okay. So you are making a R arrangement. First place, how many objects can be placed? Any of the n objects can be placed. See, if it is without repetitions, second place you will be having only n minus 1 choices. But when it is with repetition, even for the second place you are having n choices. Even for the third place you are having n choices. Even for the fourth place, you are having n choices. Even for rth place, you are having n choices. So it is n into n into n. How many times? R times. So what is the answer for this? N power r. So permutations with repetition. What is the formula for this, sir? Number of r permutations of n objects with repetitions. The answer is n power r. For example, number of outcomes when 4 coins are tossed. Suppose when 4 coins are tossed, how many outcomes are possible? Okay, you are tossing 4 times. On the first coin, there are 2 possibilities. On the second coin, there are 2 possibilities. Third coin, there are 2 possibilities. Fourth coin also, there are 2 possibilities. Am I clear? So it is not like, if you get head, you cannot get head on the second toss. It's not like that. On the first toss, you can get head. On the second toss also, same thing, you can get it. Am I clear? These 2, head, tail, can repeat any number of times. Am I clear? So we need to make a 4 arrangement of heads and tails. 4 arrangement of 2 fellows. That is heads and tails, where head can be repeated any number of times, tails can be repeated any number of times. So what is the answer for this? 2 power 4. Similarly, number of outcomes when 6 dice are rolled. So when 6 dice are rolled, 6 dice are rolled means, okay, you can say 6 dice or 3 dice, any number. Okay, let us take 6 means there may be some confusion. So let me take 3 dice are rolled. So there are 3 places to be filled. On the first day, you may get any of the 6 possibilities. On the second day, you can get any of the 6 possibilities. On the third day, you may get any of the 6 possibilities. There are 6 cube possibilities. But one important point to be noted, in general, when I say 4 coins are tossed or 3 dice are rolled, we assume that these fellows are different, distinct, distinguishable. That is, they are different coins. So it's like 1 rupee coin, 2 rupee coin, 5 rupee coin, 10 rupee coin, like that. They are distinguishable. In general, we assume by default that they are different coins, distinct coins, or distinguishable coins, or distinguishable. What do you mean by that? They are different fellows. Like, dice, there may be of 3 different color dice, red die, blue die, yellow die, something like that. Please note that in general, we assume, if it is not mentioned, by default, we assume that the coins or the dice, we assume that they are distinguishable, different, distinct fellows. That is the point to be noted. Am I clear? Now let us take some problems here, sir. If 6 dice are rolled, what is the probability that, if 6 dice are rolled, what is the probability that each of the 6 different numbers will appear exactly once? So when 6 dice are rolled, so as I told you, by default, we assume that they are distinct or distinguishable dice, different dice. Okay, by default, we assume that. Then what are the total possibilities, total outcomes? Okay. Total number of outcomes. Total means total number of outcomes. So when 6 dice are rolled, what happens? 1, 2, 3, 4, 5, 6. There are 6 possibilities on the first die. On the second die, there are 6 possible numbers possible. On the third die also, any of the 6 numbers can come. On the fourth die also, any of the 6 numbers can come. Fifth also, any of the 6 numbers can come. On the sixth also, any of the 6 numbers can come. So total number of possibilities is 6 power 6. But what is that you want? What is the probability that each of these 6 different numbers will appear exactly once? So what is the favorable situation here, sir? So you rolled 6 dice. No number should be repeated. What is that you want? No number repeated. Of course, this question you can ask only when you are having 6 dice are rolled. Maximum 6 dice are rolled, you can ask. Suppose 7 dice are rolled, he cannot ask this question. That is impossible. See, when 7 dice are rolled, you want seven different numbers. That is not possible, no? Because maximum you can have 6 numbers when dice are rolled. So this question can be asked only when number of dice rolled are 6 or less. This question can be asked only when number of dice are 6 or less. Otherwise, it cannot be asked. So here you want all the numbers to be different. So on the first die, there are 6 possibilities. Suppose you got 5. On the second die, you cannot get 5. Remaining 5 possibilities you are having. On the third one, other than the first 2 answers, remaining 4 possibilities. On this, 3 possibilities. On this, 2 possibilities. On this, 1 possibilities. That is 6 into 5 into 4 into 3 into 2, 1, 2 into 1 can be written as 6 factorial. So what is the probability that, okay, each of the 6 numbers will appear exactly once? Each of the 6 different numbers appear exactly once. So denominator is 6 power 6, numerator is 6 factorial. So that is the answer, my dear friends. Is the idea clear? Now next one. If 4 dice are rolled, that's what I told you now. If you are having less than or equal to 6 dice rolled, then this question can be asked, sir. What is the probability that each of the 4 numbers appear will be different? We are getting different outcomes. That is, when 4 dice are rolled, what is the probability that we get different outcomes? When 5 dice are rolled, what is the probability that we get different outcomes? When 6 dice are rolled, what is the probability that we get different outcomes? If 7 dice are rolled, what is the probability that we get different outcomes? That is 0. That is impossible event. Please note this point, Babu. These are all like logical questions. We can immediately understand. When the question is asked, you can understand that this question is possible up to 6 dice are rolled. You want different outcomes. You need to have 6 or less number of dice rolled. Here we are having 4 dice rolled. When 4 dice are rolled, what are the total possibilities, sir? Total is without any restriction. So there are 6 possibilities on the first day, 6 possibilities on the second day, 6 possibilities on the third day, 6 possibilities on the fourth day. So you are having total 6 power 4 possibilities. But what is the favorable thing you want? You want different outcomes. You want different outcomes. Of course, there are 2 ways of doing it. 6 possibilities, 5 possibilities, 4 possibilities, 3 possibilities. It is nothing but filling 6 numbers in 4 places or making 4 arrangement of 6 numbers. It is exactly same as 4 arrangement of 6 numbers or 4 permutation of 6 numbers. So either you can do this way or you can do it like 6p4. So what is the probability that we get different outcomes? What is the probability of getting different outcomes? Denominator is 6 power 4, numerator is 6p4. Suppose when 5 dice are rolled, what is the probability of getting different outcomes? 6 power 5 and it is 6p5. Suppose 7 dice are rolled, what is the probability of getting different outcomes? Go to hell, because it is impossible event. Is the idea clear? Hello, sir. Mahi Gupta, how are you? Thank you, Mahi Gupta. Okay, good to know that. Okay, there are some good fans for me also. Right, that is the answer for this. Okay, hope you understand. So that is the situation, my dear friends. If 4 dice are rolled, what is the probability that each of the 4 numbers that will appear? So if it is 4 dice, this is the situation. 5 dice, this is the situation. 7 dice, this is the situation. Whereas this one is for 6 dice are rolled. What is the probability of getting different outcomes? What is the probability of getting different outcomes? 6p6, that is nothing but 6 factorial. Is the idea clear? Wonderful. Next one. See, my dear friends, if you understand the previous question, for me, thank you, Mahi. Okay, I'm a big fan of Mahendra Dhoni. Your name matches. Right? Right. Very good. An elevator is, elevator in a building starts with 5 passengers and stops at 7 floors. An elevator in a building starts with 5 passengers. So we are having 5 passengers and stops at 7 floors. If every passenger is equally likely to get off at each floor and all the passengers leave independently of each other, what is the probability that no 2 passengers will get off at this same floor? So here we are having 7 floors and 5 passengers. We are having 7 floors and 5 passengers. So what are the total possibilities for 5 passengers to get off at 7 floors? Total possibilities. Number of ways 5 passengers, okay, can get off at 7 floors. That is 5 passengers maybe coming out of the lift in the 7 floors. So for the first passengers, there are 7 floors possible. He can get off at any of the 7 floors. For the second passenger, 7. Because when you are saying total, it is without any restriction. Am I clear? Third one, 7. Fourth one, 7. Fifth one, 7. So it is 7 power 5. See, if you try to make analogy between the previous problem and this problem, in the previous problem, we are having number of dice rolled and outcomes possible on each of the die. So here this 7 floors, there 6 outcomes on the dice, and these 5 passengers are number of dice rolled, 5 dice rolled. If you understand this analogy, you can directly write the answer for this, because it is like, probability of getting off at different floors or probability of getting different outcomes when 5 dice are rolled. It is equal to that. But here this number is, instead of 6, 7 is there. Assume that on a die there are 7 outcomes. Assume that on a die there are 7 outcomes. Then that problem and this problem are one and the same. This is called analogy. If you understand, you can directly write the answer for this problem without any trouble, sir. 7 power 5 and it is 7p5. That is the answer for this problem, my dear friends. With analogy, I can solve the problems. This is one very interesting methodology, my dear friends. Okay, if you understand this problem is equivalent to what problem, and if you know that problem already, no need of wasting your energy and reanalyzing the entire story. This analogy also plays very important role in mathematics. Sometimes what happens, people always solve problems, any problem, differently only. They don't try to understand the logic behind that. If you understand, I told you, the answer for this is done. Of course, let us solve it as it is, as a new problem. There are 7 floors and 5 passengers. Total possibilities. First passenger can get off at any of the 7 floors. Second passenger get off at any of the 7 floors. Third one get off at any of the 7 floors, like that. So total there are 7 power 5 possibilities. But what is the favorable situation you want, sir? The passengers will get off, no 2 passengers will get off at the same floor. That is, passengers get off on different floors. That is, passengers get off on different floors. So what is the favorable cases for this, sir? 5 passengers. For the first passenger, there are 7 possibilities. For the second one, because this fellow cannot get on the floor which the first passenger get off, so this fellow is having 6 possibilities. Next one is having 5 possibilities. Next one is having 4 possibilities. Next one is having 3 possibilities. So the answer is 7 into 6 into 5 into 4 into 3, or you can also say this like, making a 5 permutation of 7 floors. That is, 5 passengers we need to assign to 7 floors. Am I clear? So that is nothing but 7p5, my dear friends. So what is the probability that passengers get off on different floors? Passengers get off on different floors. So what is the answer for this, sir? 7 power 5, and it is 7p5. See, for me, this problem and the previous problem are same because I understand, I try to make the analogy between the concepts. Okay, there we are having outcomes, 6 different outcomes. Here we are having 7 outcomes, which are 7 floors. Okay, their number of dice rolled. Here I am having number of passengers. Okay, so a passenger is assigned to a particular floor. There a die is assigned to a particular outcome. That is called analogy between the problems, my dear friends. See, if you try to see problems this way, many complex problems can be solved just like that, sir. Okay, this is what we call it as analogy or one-to-one correspondence. Am I clear? So with one-to-one correspondence, long back I solved it, or even by this method you can solve it. Try to understand the analogy, because mathematics, I always tell this, okay, if time permits, I try to do it once again, sir. There is something called cow story. Okay, if you understand cow story, mathematics is simple like that. Am I clear? So I always tell this, so my old students might be knowing it about the cow story, right? Right. Now let us continue the story, my dear friends. Permutations with constrained repetitions. Now permutations with constrained repetitions. That is permutations with repetitions, but not all possible repetitions. Maybe like a few values or few objects can be repeated 5 times, few objects can be repeated 3 times, like that. That is with a conditional repetitions. It's not like all possible repetitions, but with conditional repetitions. So here this is the very important formula, very important concept, sir. Am I clear? So if time permits, I want to do this topic in a more detailed manner. Generally I do this in a very detailed manner for computer science students. This part, even combinations with repetitions, generally they comes under advanced counting techniques. Generally I discuss them as concepts under advanced counting techniques. Okay, so maybe for computer science students I may come up with combinatorics once again, where I discuss these topics in a very detailed manner. But here I just want to see them as formulae and how you can solve this kind of problems when they are asked together with probability. So that is what we are trying to see. So I'll try to make it a simple formula based concept here. Am I clear? Like, so now the question is number of permutations of n objects. So we are having n objects in which q1 are same. That is q1 are same objects, q2 are same. That is I am having like 10 objects, but there are not 10 different objects. 4 objects are same, 3 objects are same, 2 are same, 1 is same, like that. So actually I am having 4 objects, 1 object repeated 4 times, 1 object repeated 3 times, 1 object repeated 2 times, and 1 object repeat 1 time. That is the kind of situation. Am I clear? It is not like having unlimited supply. It is with limited supply of objects. So we are having n objects in which q1 are same, q2 are same, and so on, qk are same, where this is very important point to be noted. q1 plus q2, of course I not mentioned that, sorry for that. q1 plus q2 plus and so on, qk is equal to n. That is very important, because if you are having q1 same, q2 same, and so on, if you add, you should get total number of objects. So if that is the situation, number of arrangements of these n objects, how many ways you can arrange these n objects in which q1 are same, q2 are same, and so on, qk are same. See, that we generally denote it like this, sir. It's a kind of combinational problem. So because when the objects are same, suppose we are having 4 A's, how many ways you can arrange them, sir? If you are having 4 A's, how many ways you can arrange them? Only 1 way. Because of that, so it can also be seen like a particular kind of combinational problem. Number of combination of n objects where q1 are same, q2 are same, and so on, qk are same. So what is the answer for this, my dear friend? That is given by the following formula: n factorial by q1 factorial into q2 factorial and so on, qk factorial. Of course, this can also be written in another way, and so on, qk. There is one more way of doing it, because out of n, q1 are same. So first select q1 places for those fellows. First select q1 places for those fellows. And those q1 can be arranged only in one way. So that is the answer. That is selection and arrangement also done. Now remaining how many? n minus q1. From this, select q2 places for the second type of objects, q2 same objects, and so on. You can continue q1 minus q2 minus qk minus 1 c qk. Even this is one and the same, my dear friends. Okay, I'll just give you the idea, sir. For simple understanding, I'll give you the idea. Suppose you are having 7 objects in which 3 are same, 2 are same, and 2 are same. You are having 7 objects in which 3 are same, 2 are same, and 2 are same. How many ways you can arrange these 7 objects? One way of doing it is 7 factorial by 3 factorial into 2 factorial into 2 factorial. See, some people feel this as probability. It is not probability. See, generally whenever you write P by Q form, they feel like probability. It is just counting, sir. We are finding how many possibilities, how many arrangements of these n objects are there in which q1 are same, q2 are same, and qk are same. Am I clear? So how many ways you can arrange 7 objects in which 3 are same, 2 are same, and 2 are same? It may be like, you know, how many ways you can arrange these 7 letters in which 3 are same, 2 are same, and 2 are same? That is the question. So what is the answer? 7 factorial by 3 factorial into 2 factorial into 2 factorial. That is nothing but, if you cancel 3 factorial, you get 7 into 6 into 5 into 4, 3 factorial gone, 2 factorial into 2 factorial, that is 4 is gone. Okay, 7 sixers, 42, 42 fives, 210. So the answer is 210 for this. And the other way of doing it is, number of arrangements of 7 objects in which 3 are same, 2 are same, 2 are same can also be done like, you know, from 7 first select 3 places for these 3 objects which are same. Now how many more remaining? 4 remaining. From 4 select 2 places for 2 which are same. Now how many are remaining? 2. From 2 select 2 places for remaining 2. And if you simplify, you see your answer is exactly same. So these two are one and the same, sir. Whether you do this way or you do this way, you get the same answer, my dear. These are the 2 ways of handling this particular permutations with constrained repetitions. Am I clear? So let us take one problem here. The letters of the word Katappa, okay, are arranged. Find the probability that all 3 A's are together. So here Katappa is the word, okay, in which total how many letters are there? 8 letters are there, in which you know, 3 A's are there, 3 same, 2 T's are there, 2 P's are there, and 1 K is there. These are 3 A's, 2 T's, 2 P's, and 1 K. So how many ways you can arrange the letters of the word Katappa? The number of ways of arranging the letters in the word Katappa. How many ways you can arrange the letters in the word Katappa? That is 8 factorial by 3 factorial into 2 factorial into 2 factorial into 1 factorial. 1 factorial I am ignoring. If you want, you can write down. So that is the number of ways of arranging the letters in the word Katappa Babu. But now what is the question? There is a condition. This is the total possibility. Now what about the favorable situation? You want 3 A's together. So you need to arrange the letters of the word Katappa in such a way that the 3 A's should be together. So whenever you want some of the objects together, you take it as 1 unit. This is 1 unit. And remaining 1 unit, remaining how many? Because 3 gone, remaining 5 units. So total how many units you are having? 6 units. But these 6 units are not different. In the 6, 2 are same, which are T's, 2 are same, which are P's, 1 is same, which is K, and 1 is block of 3 A's. See, this unit is block of 3 A's. Please try to understand. Now how many ways you can arrange them in a row? The number of arrangements of 6 objects in which 2 are same, 2 are same, 1 is same, 1 is same. That is nothing but 6 factorial by 2 factorial into 2 factorial into 1 factorial into 1 factorial. And for each of these arrangements, the 3A's can be arranged in how many ways? For each of these, the 3A's can be arranged in how many ways? See, I told you now, when the A's are same, they can be arranged in only one way. They can be arranged in only one way. So what about the favorable situations? What about the favorable situation, my dear friends? The favorable situation is, what is that? 3A's together. Simply this into 1, that is 6 factorial by 2 factorial into 2 factorial. So what is the probability that the 3A's are together? What is the probability that the 3A's are together? Denominator is total, numerator is favorable. Favorable is 6 factorial by 2 factorial into 2 factorial. Denominator is 8 factorial by 3 factorial into 2 factorial into 2 factorial. Simplify to get the required answer, babu. Okay, you try to simplify this to get the required answer. Am I clear? So that is the idea, my dear friends. Clear? So this is a homework problem for you. Am I clear? This is a homework problem. Of course, tomorrow's topic, I call it as addition theorem. Mainly we talk about addition theorem, but I also do combinations with repetitions tomorrow. Okay. So because addition theorem is a small topic, so we try to do that together with combinations with repetitions, and addition theorem tomorrow we try to do it. If possible, we try to take some special problems, my dear friends. Okay. So this is the homework. Please try to write your answer in comment box. Okay. So that's all for today. You can also reach me. This is my Telegram group, and this is my app where you find the individual courses for one day also. So there is a 1 day subscription. Okay. So you can take 1 day subscription to check it out how that particular course is. If you like it, you can just go through it or take that particular course. Okay. We are going to launch more courses in that particular, app. Now, right now we are having only a few courses. Okay. For computer science students, we have few courses. For electronics and communication student also, we launched one course by Sridhar Reddy sir. Okay. Famous faculty for analog and communications. Okay. That particular course is also launched, but that is for, 3-month subscription. So you can take any of the subscriptions. Okay. Or you can follow us on our our YouTube channel, my dear friend. This is our YouTube channel. So please subscribe and press the bell icon so that you can get the regular updates about our classes. Okay. See, my dear friends, we'll be not announcing the classes 1 week prior, 2 weeks prior, 1 day prior. We announce and we conduct the classes, my dear friends. So those who are interested can take the classes at any time. Am I clear? So that's all for today. If you have any doubts or any thing to tell, you can talk to us. Am I clear? So I'm closing today's session here. Tomorrow, when we meet, we talk about combinations with repetitions, and we talk about addition theorem. Okay. That's all for today. Thank you.